Unfortunately, I think my computer filled up with the memory spaces got filled up. I was recording so much video to put together for you guys that it cut off my lecture notes that I did on combustion reactions. However, I will include a link so that you guys can see what my PowerPoint looks like and get a feel for that. And you've seen some of my KWLs and what I've done with that, as well as my interaction with the projects. And then this will include some interaction with the demonstration. And then what happened was, after we did the notes, I just went back and I had the students connect the idea that the less dense, we made the starch less dense, and then it allowed it to burn because it would have more space for both reactants, the starch and the oxygen, and they connected those two ideas together. Unfortunately, we didn't get that recorded. And I also managed to, but I did manage to record another thing that I love to do in my classroom, which is have the students go over their own work. Rather than me reviewing the correct answers, they review the correct answers with each other, which is really excellent. So overall, hopefully this will give you a good idea of what I'm like in the classroom, but if you need anything else or any other information, please let me know. Thank you so much. This is cornstarch. Cornstarch is an organic molecule. Okay. So we see a little bit, we see it burning a little, right? But is it really lighting itself on fire? Why do you think that is? As soon as we take the flame away, it stops. Now, we do this.
Whoa!
What do you guys think the difference is? What was the difference when I was breathing it out than when it was on the table? It was moving? Okay, so movement helps? Why would the movement help? What would movement do?
Sort of expand it.
Expand it? Okay, what does expand mean? Okay, larger. So did the amount of starch change? So the amount of starch is the same, but it was expanded. So when we expand something and we keep the same amount of it, what is that? What do we call that? We call that less. Starts with a D. Dense. It's less dense. So here it's very dense and compact. Expel, it's very loose, expanded. What's going on with number one?
The first one is methane, CH4 plus oxygen equals O2. When oxygen is alone, that's another one. And then of course it equals CO2 plus H2. So it's combustion. Things too. So I just balance it out. Add 2 there, and then add H2. 4.
Excellent. What is the next one?
The next one is ethane plus oxygen, which is CO2 mix 6 plus oxygen, which is 2, and it equals the same thing again. So I did some crazy stuff here. I did actually first 6, 12, 6 here. And yeah, the oxygen equals 15 further.
Okay. And now I have a question. Okay, yeah, so 2 times 2, 4. Exactly. Excellent. So Are you guys sensing a theme here? What's the hardest part of these equations? Balancing them. Very good. Okay, propane.
Propane is C3H8 plus oxygen. And you do the same thing as the other two and balance it out by just the oxygen's really in that.
Excellent. Ian, hop on up there. You did them wrong? Well, let's fix them. Hop on up there. Let's do 4 and 5. Remember, we celebrate mistakes in science. That means it's something we can learn from. Okay, so let's look at 4. Well, so far, I see what you have the butane, good. You have the oxygen, and what do you have the last part? Okay, so what's your mistake? You thought oxygen was 1, there was only 1 oxygen, you thought it was 01? Okay, so everyone has to remember, guys, all of our halogens plus oxygen and nitrogen, always in that gas form. O2, N2, F2, always. Halogens, oxygen, nitrogen. So it's good that you figured out your mistake. Now, show us how you're going to balance this. Okay, so you have 2 oxygen here, 2 here, and 2 here. So total, how many do you need on this side? Okay? So 2 times 3 would be 6. Is that what you want? 2 times 3 is 6, and then over there. Okay? Now you have 5 oxygen. I think you might have been there the first time. Do you want to pick something besides oxygen? Why don't we start with carbon or hydrogen? Remember, don't we usually save oxygen and hydrogen last and we start with carbon? So, okay, good. There we go. I think we're cooking now. Okay, next, we can look at hydrogen or carbon. Since we have hydrogen right here, let's go ahead and look at that.